This video is about the process of nuclear fission, and it will be explaining the basic principles of how a nuclear reactor works using the energy obtained from fission. The process of nuclear fission involves a neutron and an unstable large nucleus such as uranium-235 or 238. The reason why this nucleus is considered unstable is because it is an isotope of the original uranium element and contains too many neutrons. So when it absorbs another neutron, this causes it to split into two other fission fragments, known as daughter nuclei. Also, two more neutrons are released as a result, as well as energy. This reaction is known as nuclear fission. The energy given off during this reaction is equivalent to 1 mega-electron-volt. It is important to remember that mass energy is always conserved during this reaction. Therefore, in order for this reaction to work, the mass before has to be bigger than the mass after, because some of the original mass was converted into energy. Hence, mass energy before equals mass energy after. For example, if the mass before was 100, the mass afterwards of the two fission fragments will be, for example, 90. Therefore, a mass of 10 was converted into energy. This reaction is known as a self-sustaining chain reaction because it produces more neutrons, and these neutrons will then go off to split more uranium nuclei, hence releasing more energy. Nuclear reactors are the modern-day devices extensively used for power generation, as the traditional fossil fuels, like coal, are at the breach of depletion. This is how a basic nuclear reactor looks like. It consists of three components: a reactor core, a water container, and a generator. The basic idea behind it is that the heat produced from nuclear fission reactions is passed through the water container. This intensive heat causes the water temperature to rise and evaporates some of the water into steam. This steam then passes to the generator, where it is used to drive the turbine. In the generator, there is a magnetic field present, as you can see, which flows from north to south, and the turbine is moving inside the magnetic field. As the turbine rotates through the flux lines, it has to cut them, and whenever a conductor cuts flux, it induces an EMF across the conductor, hence generating a current in the circuit the turbine is connected to. We know this process is called electromagnetic induction. Now we will look closely inside the reactor core. Inside the reactor core, there are fuel elements, which are shaped like thin rods, which contain fissionable nuclei, uranium-235 and 238. Also control rods, which vary in number according to the size of the reactor, and a moderator, which has the capability to slow down these high-energy neutrons, which are products of the fission reactions, making them into thermal neutrons. The role of the control rods is to primarily control the rate of reaction by controlling the number of spare neutrons available at any given time. They are usually made of boron or cadmium. The rate of nuclear fission reactions can be controlled, producing a steady output of energy by inserting or removing the control rods accordingly. Water is usually used as the moderator. The role of the moderator is to slow down the high-energy neutrons which are released after each fission reaction, and make them into thermal neutrons. The high-energy neutrons are 500 times less likely to participate in another fission process, which is not very useful for the chain reaction. As a result, water is used to slow them down, as water molecules bump into the high-energy neutrons, causing them to lose some of their energy, hence turning them into thermal neutrons. So they can be used again for more fission reactions by splitting up the uranium nuclei. I hope you found this video interesting. Thanks for listening.